Hey, Valen, thank you. Hello, everyone. Thanks for joining us today as we talk about Azure Firewall Monitoring, Management, and Troubleshooting. My name is Gustavo Modena, and I'm a product manager on the Customer Experience and Engineering team for Azure Network Security products. And joining me today is my colleague, David Frazee. In this webinar today, we'll dive into the Azure Firewall tools, features, and techniques that will empower you to effectively monitor, manage, and troubleshoot your Azure Firewall deployments. And we're excited to talk about this topic here today, since we always get a lot of great feedback from the entire community. And please, if you have any questions during the presentation, please feel free to put them in the chat as we present. We have a great team here joining us today that will be monitoring the chat, and we'll try to answer as many questions as they can. All right, so let's cover the agenda for today. We'll first start with a general overview of Azure Firewall. Then next we'll talk about monitoring, management, and troubleshooting, showing the features that will help you on your journey with Azure Firewall. And at the end of each section, we'll have a live demo, right? We'll give you all an opportunity at the end of the session to cover questions or concerns that are not answered, and to address any unanswered anything that might be beneficial for the community as well. Okay, so let's start with our Azure Firewall overview. The Azure Firewall is our first-party fully managed next-generation firewall with built-in high availability and unrestricted cloud scalability. It's a fully stateful firewall that provides both east-west and north-south traffic inspection for your environment, right? The key benefits of the Azure Firewall is network and application traffic filtering for incoming and outgoing traffic. Azure Firewall allows to create and enforce rules for traffic filtering based on many criteria, such as source and destination IP addresses, ports, and protocols. It also supports filtering for specific applications and services, such as Azure PaaS services using application level rules. It has a built-in threat intelligence to alert and deny traffic from and to non-malicious IP addresses, FQDNs, and URLs. It deploys and scales in minutes. And again, it supports east-west and north-south traffic. There are 3 supported SKUs for Azure Firewall today. The first one is the basic SKU, which is intended to deliver the essential protections that small and medium-sized customers need at an affordable price. But it can also be used by large enterprise companies, with smaller line of business or other use cases. Then we have the standard SKU, which is recommended for customers looking for a layer 3 to layer 7 firewall that needs auto scaling to handle peak traffic periods up to 30 gigabits per second. The standard SKU also supports enterprise features like threat intelligence, DNS proxy, custom DNS configurations, and web categories. And lastly, we have the premium SKU, which is recommended to secure highly sensitive applications in regulated environments, such as payment and healthcare industries. It supports advanced threat protection capabilities like intrusion detection and prevention, like IDPS, TLS inspection, and URL filtering for application rules and web categories. The premium SKU can also handle up to 100 gigabits of network throughput and up to 10 gigabits for FedFlow support. When it comes to the feature comparison of the 3 SKUs, we can see the features listed in this table here. Just highlighting some of the differences. So for example, for basic, we don't have the network level FQDN filtering. It's only available for the standard and premium. Then another thing I wanted to highlight here is the cloud scalability and the throughput capacity. So here we can see the difference between basic, standard, and premium. Then FedFlow supports another difference that it's important to highlight here. Basic SKU doesn't have it, while standard SKU has up to 1 gigabits and premium 10 gigabits. Then for web categories, web content filtering Basic doesn't have it. It's only available for the standard and premium. DNS proxy and custom DNS only available for standard and premium. Threat intelligence is available for basic only in alert mode. If you want to use alert and deny, you're going to need to go with that. And then the premium features only available for the premium SKU, like inbound TLS inspection by using app gateway, outbound TLS termination, fully managed IDPS, and URL filtering for, full path. Okay, so now that we know what Azure Firewall is and what are the SKU availables, we're gonna, we're gonna start covering the monitoring section, right? So Azure Firewall will block unwanted traffic from entering or leaving your network, protecting your data and systems from hackers, malware, and viruses. However, Azure Firewall also needs constant monitoring and updating to match the network changes and cyber threats. Monitoring Azure Firewall, ensures that firewall rules are up to date, effective, and appropriate configured, preventing problems like service disruption, data breach, or system compromise. Monitoring the network firewalls, Azure Firewall also helps detecting and responding to any suspicious and malicious activity on the network. Therefore, monitoring network firewalls is essential for network security and data protection. And in order to start monitoring our Azure Firewall deployments, we're going to go through some of the features available. So let's get started talking about the Azure Diagnose setting, which is a feature that allows us to send, Azure platform metrics and logs to different destinations, such as Azure Monitor logs, Azure Storage, and Azure Event Hubs. We recommend using Diagnose settings to monitor and troubleshoot all your firewall deployments. When creating a diagnose setting for Azure Firewall, there are two destination table options. One is Azure Diagnostic, and the other one is the resource specific, also known as structure logs. The structure logs are a type of log that are organized in a specific format. They use a predefined schema to structure log data in a way that makes it easy to search, filter, and analyze the data. Unlike Azure Diagnostics, or also known as unstructured logs, which consist of free-form text, right? So the structure logs have a consistent format that can be parsed and analyzed by machines. And the Azure Firewall structure logs provides a more detailed view of firewall events. They include information such as source and destination IP addresses, protocols, port numbers, and action taken by the firewall in different columns. They also include additional metadata, such as time of the event and the name of the Azure Firewall instance. By using the resource-specific tables instead of the existing Azure Diagnostic table, we can choose enabling different log categories, which are now dedicated to specific features, as for example, IDPS and threat intelligence logs. In case we still need to use Azure Diagnose tables and resource-specific logs, we're going to need to create two diagnose settings because we are not able to have a mix of logs, just one diagnose setting. When the resource-specific mode selected, or the structure logs, right? We are enabling structure logs schema and individual tables, in the selected log analytics workspace are created for each category selected in the diagnose settings. This is recommended method, since it's easier to work with the data in log queries, providing better discoverability of schema and their structure, improving performance across both ingestion latency and query times. And then it also gives you the ability to grant Azure RBAC rights on specific tables. Structure logs also helps us with cost optimization, since it's expected a cost saving of log analytics ingestion of around 70 to 8% of Azure Firewall. So here in this screenshot, we have the categories that are available. We can see the first three categories are not selected because these are for legacy Azure Diagnostics, or when you select the destination table being the Azure Diagnose table. And then if you are going to use the structure log, which is the one that we are recommending, you will need to select the following categories. So starting from the Azure Firewall Network rule up to into the flow trace log. So these are all the new categories that have been enabled with the resource specific logging. So this is just I know it might not be very good reading these screenshots here, but this is just an example showing the difference how you write the custom query when you're using the Azure Diagnostic logs. Because since all the information, source IP, source port, destination IP port, and all the other data is under just one column, in order to have these separate views or separate columns showing the data, you're going to need to write a more complex query. Parsing the data, you need to understand the structure of the logs to create the definitions of the parsing. So it's a little bit more complex to deal with the logs when you're using Azure Diagnostics. While if you start using the structure logs, this is this is how the logs will look like. So the query itself is it's a more simple query because you don't need to do any kind of parsing, because all the structure, all the schema of these new tables are already separating the data into different columns. So we already we don't need to do any parsing. We don't need to understand how the logs are written to create the parsing accordingly. So we only need to know what's the schema and then provide the conditions for our query and then get the data in a formatted way. Okay, so next, since we just covered the logging, the structured logs, let's talk about the embedded workbook. In Azure, workbooks provide a flexible canvas for data analysis and the creation of rich visual reports within the Azure portal, right? So it allows you to tap into multiple data sources from across Azure and combine them into unified interactive experiences. And it also let you combine multiple kinds of visualization and analysis, making them great for free-form exploration. The Azure Firewall workbooks being available for a long time now, but we are now making it attached to your Azure Firewall, so you don't need to deploy it anymore from the GitHub or from the Sentinel solution, even though those are still available. But once you have the logs available, you're gonna see the data showing up on your workbooks. So again, the Azure Firewall Portal has now this embedded view capability, allowing all the customers to easily perform data analysis for the Azure Firewall traffic. You can use it to create visual reports within the Azure portal and tap into multiple files deployed across Azure and combine them into unified interactive experiences. This embedded workbook provides you with aggregated information in the form of charts and logs, and it has different sections such as application rules, network rules, DNS proxy, ADPS, and a new tab that has just been added for threat intelligence, and the investigation tab as well. The workbook is designed to work across multi-tenants, multi-subscriptions, and multiple firewalls, and it allows you to filter your firewalls and resource groups and dynamically filter per category with easy-to-read data sets with when you are investigating an issue in your logs. And then talking a little bit about the Azure Firewall solution for Microsoft Sentinel. We know that many organizations around the globe are heavily investing, in products and technology to prevent breaches, and having automated threat detection and response capabilities to identify malicious actors and actions in their environment has become a high priority topic. The cloud native Azure Firewall provides this protection against network-based threats, while the Microsoft Sentinel provides threat detection, hunting queries, automated response capabilities for the Azure Firewall. Here at Microsoft, we are always looking for for improving the products, improving the integration with the Microsoft Sentinel. We continue to innovate best security detection and response experiences in the Azure Firewall solution. Previously, the Azure Firewall solution for Microsoft Sentinel only supported for Azure Diagnostics. We recently updated all the solution to support structured logs as well. So once you start using the structure logs, you can your solution is already is ready to deal with these new logs. So it should work in the same way as it was working for diagnosed logs. So you can use the queries, you can enable the playbooks for instant response. You can keep using the same firewall solution for Microsoft Sentinel as you were using before, to help you monitor and keep active, proactive monitoring your environment and all your firewall deployments. Okay, so now we have covered the monitoring section. I will hand it over to David, who will be doing the demo. David.
Thanks, Gustavo. I'll get started here. All right, I'm sure that you can see my screen here. So I'll start here at the Firewall Manager blade to show you what Gustavo was just talking about when it came to monitoring the Azure Firewall. So I'll come to Azure Firewalls first, and we'll just go directly to the firewall to see these actual the logs and the workbooks that we just mentioned. So here in the Azure Firewall blade, first thing I want to show you is actually the diagnostic settings, where this is where we will come to actually configure the structured logs or Azure Diagnostics. But as Gustavo mentioned, we do recommend that you move to the newer structured logs when it comes to analyzing what's going through your Azure Firewall. So if you were to come to diagnostic settings, you could either add a diagnostic setting or create a new one or edit one as well. And as you can see here, we have 3 settings that are at the top and that they're clearly labeled legacy. And so these are specifically for the Azure Diagnostics table, which would require that more parsing than we would really want you to have to be able to do. What you will then have to do is just select these ones that don't have any type of legacy attached to it within the parentheses. But if you are going to use some of our other features that Gustavo will mention here a little bit later called policy analytics, make sure that you do have these selected as well. What's really important is once you send these to this log analytics workspace, that you make sure that you click on resource specific for the destination table, just to ensure that this is going to the correct log analytics tables. So when you go to query them against the Azure Firewall, everything will come through as expected. But it's a very simple configuration. Come here, deselect to legacies, and make sure to send it to resource specific. Okay, so once you have the diagnostic setting set up and you start to have traffic flow through your Azure Firewall, you can start to actually check against the logs here. And so we'll come in here. I'll just close this out a little bit, and I'm going to come to queries. So this, if you have an Azure Firewall, from what I've been testing at least, we can see all of these queries, or these queries are already baked in. If you want to come in here, you will have to do a filter for the resource type firewalls, but you will see these firewall logs and then firewall logs resource specific tables to just kind of help you out. The first thing I'm going to do though is I'm going to show you the network rule for Azure Diagnostics. And I'll just do a quick run of this. All right. So in the Azure Diagnostics, for this log, I mean, we do have some really great information, right? So we have our time generated, we have details within our message, but then we also have a lot of the really necessary information that we need. So the 5-tuple type information. We have our protocols, our source IP and our destination IP, source port and our target port, as well as the action. But to get that type of information, it's really, we really want you to understand that to pull this information out, we needed at least 39 lines of a Custo query. Granted, some of these are comment lines out, but it's still quite a complicated query to be able to get the information that you need. So really, this is where partial of the resource-specific logs came into play. So now let's just check this out. I'll load this to the editor. And we can see really what we're doing. We're just going against the Azure Firewall network rule. And I'm just asking it to give me the first 100 results here. And here we have a lot of great information. We still have the same great information without any of the necessary or the necessary parsing that came with Azure Diagnostics. Very simple to learn, very simple to use, and we're still getting everything that you need to know when it comes to analyzing the Azure Firewall, ensuring that what's going through needs to be going through and what's being denied is being denied. So it's a very powerful way to use your Azure Firewall in a very easy manner as well, rather than using the Azure Diagnostics and having to parse through all of these types of logs. If you're already using Azure Diagnostics today, you can just go into the diagnostic settings and just turn on the structured logs in a separate diagnostic setting. There won't be any issues here. You can then go and test out the resource specific type logs. And then if you're happy with them, as Gustavo mentioned, this could save you in cost in the future there. So next that I'm going to talk about is the workbook. So this is embedded as mentioned. You did used to have to either deploy this through our GitHub repo, or if you were going to use Microsoft Sentinel, this would be baked into one of the solutions. But today the work has been done to get this integrated directly into the Azure Firewall blades, if this is the way that you want to monitor this. So really here, I'm just going to select my log analytics workspace. And over here, now we're getting all of our information for this specific firewall. It says all over here, but we only have one that it's really looking at. So for the last 90 days on this Azure Firewall, we can see in the overview blade, at least events over time, snap port utilization, throughput that's going through the firewall, and some hit counts here as well. It's really useful when it comes to application rules, network rules. You'll be able to see what's being denied, what's being allowed. And then you can really get to see and understand through time what is going on through the Azure Firewall. I do want to show the IDPS and threat intelligence here. And this might just look a little bit cut off because I'm zoomed in a little bit on my browser here. But if you're going to use the premium SKU for the Azure Firewall, you will be able to use this visualizer to see what's going on when it comes to IDPS events and specifically threat intelligence events within the Azure Firewall here. And as Gustavo mentioned, this tab, Threat Intelligence, this is actually a brand new tab that was just recently pushed to this. So it's very useful. This was an ask for some of our customers here, so make sure that this was put in there. Okay, so this is the embedded workbook. This embedded workbook, I fairly positive this is working on structured logs. So you will need to use structured logs for this. If you want to still use Azure Diagnostics for the workbook, you will be able to just go to the GitHub repo and be able to deploy it as well. But if you want to use this embedded workbook, you will have to be using the structured logs here. Next, the last thing I want to show you for this portion is within the Microsoft Sentinel workspace. So if you are using Microsoft Sentinel for part of your solution and you want to use that to help monitor your Azure Firewall and what's going through that, an easy way to come do this is come to the Content Hub. And then we'll search for Azure Firewall here. And we should see this within our Content Hub. I've already had this deployed, so the actions for me will be to just manage and then to go to the other actions. If you don't have this deployed already, there will be an option to publish this. But what comes with the Microsoft Sentinel Azure Firewall solution will be multiple analytic rules that you can use to create incidents, as well as multiple hunter queries that could help you define what's going on and what's going through. Both the workbooks for Azure Diagnostics and structured logs are part of this package as well. So if you just use the Microsoft Sentinel to monitor everything for the Azure Firewall, everything that we've been showing you here, minus really the log analytics workspace, will be available to you in the Microsoft Sentinel. The connector is here, as well as some additional playbooks if there's anything that you want to do when it comes to automation, dependent on the analytic rules or the hunter queries here. But that's it for my part on monitoring. I'll hand it back over to you, Gustavo.
Hey, thanks, Frazee. Okay, so let's talk about the management capabilities for Azure Firewall. Um, my screen is shared. Yeah, it's shared. Okay, so the first thing I want to start with is talking about the management, right? We can do management via Azure Firewall, via Azure Portal in some different ways. So let's start with managing. Managing Azure Firewalls has become simplified with the introduction of a top-level resource that the Azure, which is the Azure Firewall policy, right? A FIDO policy helps you organize, prioritize, and processes the rule sets based on hierarchy with rule collection groups, rule collections, and rules. A, a rule collection group is used to group rule collections. They are the first unit to be processed by the Azure FIDO, and they follow a priority order based on values. There are 3 default rule collection groups. And their priority values are preset by design. Even though you can't delete these default rule collection groups or modify them, modify their priority values, you can manipulate them, the processing order in different ways. If you need to define a priority order that is different than the default design, you can create a custom rule collection group with your wanted priority values. In case you don't use the default rule collection groups at all, and use only the ones you create to customize the processing logic, right? The rule collection groups, they can contain one or multiple rule collections, which can be of the type DNet, network, or application. A rule collection always belongs to a rule collection group, and it contains one or more rules. They are the second unit processed by the Azure Firewall, and they follow a priority order based on values. The the rule collections must have a defined action, either allow or deny, and a priority value. The defined action applies to all the rules within the rule collection, and the priority value determines the order the rule collections are going to be processed. The rule types must match their parent rule collection category. For example, a DNet rule can only be part of a DNet rule collection. So here in the diagram, we have just a representation of the FIDO policy, different rule collections, different rule collection groups, rule collections within each one of the rule collection groups, and the rules that we have within each rule collection. The Azure Firewall policies also can be used within a hierarchy to enforce compliance throughout all Azure Firewall deployments in Azure. Child policies will always inherit the mandated organizational standards that are configured in the base policy. These inheritance allows the DevOps to create local firewall policies on top of organization mandated base policies to customize the rule sets for specific workloads. The policies created with non-empty parent policies inherit all the rule collections from the parent policy, and the base policy and the child policy must be in the same region. But by having the base policy and the child policy in the same region, you can use these across different firewalls deployed across different regions, regardless of where they are stored. Just to add here that the FIDO policy it's a global resource, so you can have a FIDO policy deployed in East to West 2 and use this policy, attach this policy to a FIDO which is deployed in Europe or another region. So okay, so the network rules, rule collections, inherited from a parent policy are always prioritized over network rule collections, defined as part of the child policy. This same logic applies to application rules. When it comes to processing the type of rules. However, network rule collections are always processed before application rule collections, regardless of the inheritance. When it comes to hierarchy, we can enable threat intelligence mode because it's also inherited from the parent policy. we can set it, set the threat intelligence mode to a different value to override this behavior, but we cannot turn it off. So let's say we have the threat intelligence enabled at the parent policy, and then someone wants to disable it in the child policy. It's not possible. It's only possible to override with a stricter value, but not disable. Like threat intelligence mode, the threat intelligence allow list is also inherited from a parent policy. The child policy can add more IP addresses to the allow list. And the last part here is the net rule collections. Those are not inherited because, net rules, they are specific to a given file. So we cannot have the net rules on a parent policy, which is, used across different firewalls. So that's a heads up here. With the inheritance, any changes to the parent policy are automatically applied down to the associated child policies. Okay, so next we're going to talk about the policy analytics. Policy analytics is a feature that provides insights, centralized visibility, and control to your Azure firewalls. The firewall rules and policies might be difficult to manage, especially for big organizations that have locations across the world. And network admins, they need to keep the firewall rules up to date, handle existing rules, and delete rules that are no longer needed. And when you have a large environment with many people managing it, it can be a complex task, right? So the policy analytics is a powerful tool that not only helps with monitoring, but also managing the Azure firewall and firewall rules. It enables network admins to improve their security and compliance posture and simplify the overall management. It also provides us with a comprehensive view of our firewall rules and policies and help us optimize them with an easy and confidence. So here in this screenshot, we have just a quick view of what policy analytics brings to when it comes to management, right? So we can see the policy limits to know if we are getting close to the limits of each policy. We can get to know if we have rules that are using multiple IP addresses, and then there is a recommendation to use IP groups instead of managing those IP addresses rule by rule. We can see if there are rules with low utilization, and then we can improve the rule management by disabling rules that are not needed, or even to move those rules to a low priority processing. And then here we can also see, some of the flows, right? What are the flows hitting your network rules, application rules, and DNet? So it gives a really good view of your environment, how your rules are configured, and it by using the single rule analysis, you can also see what can be improved based on the traffic that's going through your Azure firewall. All right, so as when I started this section, I mentioned about different ways of managing Azure Firewall, right? There are different methods available to put to put hands-on keys for management portion of the firewall. With the two main methods being the utilization of user interface or Azure portal, and the other method is to use infrastructure as a code. Infra as a code is a method of managing and provisioning IT resources through machine readable definition files rather than physical hardware configuration or interactive configuration tools. Infra as a code can help automate and deployment and the configuration of the Azure firewall. Some of the benefits of using it, using Infra as a code is the consistency and reliability, which ensures that the Azure firewall settings are consistent across different environments and deployments, reducing human errors and configuration drifts. It also has the benefit of compliance and security, because it allows enforcing and auditing the Azure firewall policies and rules, ensuring compliance with organization and regulatory standards, and enhancing security posture. And the other benefit is about cost efficiency and productivity, which reduces the operational overhead and complexity of managing the Azure Firewall, saving time and money and improving the productivity and efficiency. We can use different flavors of infra as a code for Azure Firewall management. There are first-party management tools like Bicep, ARM templates, Azure CLI, and Azure PowerShell. But if you have a multi-cloud stance and want to use a single provider to manage resources across clouds, then we recommend using Terraform for this level of management. Here on the screenshot, we have some examples of using Bicep, ARM templates, and Terraform. But David will also drive and show these in our demo. David will take over right now and gives the demonstration of managing Azure Firewall.
All right, thank you, Gustavo. All right, so here we go. We're going to be talking about everything that Gustavo just talked about in the management portion. So this is the rule collections. We'll kind of touch base on a little bit of the parent policy. We'll look at policy analytics, and then I'll just quickly show you within Visual Studio Code just an example template of Bicep and Terraform. So let's get started here with the rule collections. So really what I want to show you here is just an example of one of the ways that we would recommend you to configure your rule collection groups. As mentioned, every Azure Firewall policy will come with some default rule collection groups, the default DNet, default network, and the default application. If you were to use those default rule collection groups, and let's just say you put all of your application rules within that default application one, and you don't really take into consideration the scale of the enterprise or the scale of the business, and you continue to just put every single application rule within there, your rule collection group will eventually hit our 2 megabyte limit for size. And then you'll have to determine how you're going to create new rule collection groups to move forward. So really what we want to do is we want to recommend ways that you could create these collection groups so that you could just be ready for scale, ready for any type of growth that you might have within Azure. And so here we have some examples of workloads within different environments, workload 1 in production, workload 1 dev, workload 2 production, and so on and so forth. Workload 1, this could be its own virtual network. Right, so you could either say this is virtual network 1-production or just workload 1-production. But really what you want to do is if you, let's say you have a very specific spoke network that's going to peer to your hub where we would recommend that Azure Firewall sit, then you would say, hey, I just want to ensure that for this spoke network that handles workload 1, these rules are in place. Everything here is in place, and I'm not really worried about all my other spoke networks when it comes to this rule collection group. So within that, you'll be able to define whether you're going to have some DNet rules specifically for production for that virtual network, and then whether or not you're going to have some network allow and network deny type rules, as well as application allow and application deny. So whenever you do this, then you isolate really what's going to happen between your different spoke networks. And to kind of touch on this a little bit more, so let's say you have workload 1 production, it needs to communicate to workload 2 production across a network rule. The recommendation here is that if the workload 1 is the requirement, it is the one that has the need to make the communication out to workload 2 or workload 3 or so on and so forth, then you would create that rule within the workload 1 rule collection group. You won't need to make that rule within the workload 2 because workload 2 doesn't have that requirement. So this is a way that we would, define a rule collection group just to be able for you to continue to scale and grow within Azure. And then as you can see here, I also have some rule collection groups for legal, for finance. So if you also are completely out of an on-premises environment now and you manage everything within Azure and all your resources are within Azure, you could also just as well create rule collection groups for different pieces of the business that might need to be able to go out into the internet or communicate to other services within your organization. So that is an example of rule collection groups that we really recommend that people use, really just so that you don't get really complicated when it comes to utilizing default rule collection groups. As you can see here, we say the default rule collection groups, you can't delete them, but you don't see them here in my firewall policy because I'm just not using them at all. So because I'm not using them, you're not going to be able to see them. So we do recommend that you would go along this route and then just create some groups for specific workloads or specific virtual networks or specific portions of the business. And then so next to kind of touch on this, so if you wanted to do a hierarchy of policies and you wanted to enable a parent policy, it would have to be the same SKU. This firewall policy here specifically is a standard SKU. You would be able to then come and select one that's within the same region and within the same SKU. That parent policy would then apply its own rule collection groups minus DNAT rules to this child policy. It would also then integrate with threat intelligence, TLS inspection if this was a premium SKU, IDPS if this was a premium SKU, and as well as some other things as well. So that's how the parent policy will work there, and it is a really good way to at least set up an organization-wide type policy while allowing you to create very specific type rules for specific workloads down to these child policies here. All right, next I'm going to go back to my actual demo environment and show you policy analytics. So within policy analytics, we do have some good blades here, especially in the insights. We show policy limits. So if you're going to be hitting really close to specific limits in unique source and destination IPs, we'll be able to show you that. We'll also be able to show you if you're currently reaching your max limit of IP groups, if you are utilizing IP groups. To kind of touch on that, we do recommend to use IP groups as it will greatly reduce the amount of unique source and destination IPs that your Azure Firewall is counting against. But there's other insights here, rules with multiple IP addresses, rules with low utilization, or just rules that have actually no hits. If you start to see that this rules with no hits start to continue to grow and to grow, and you're concerned about the size of your rule collection group, you can always come in here, determine what's not getting used, and start to, trying to trim the fat of the rule collection group or that firewall policy. We can see redundant rules, and specifically, so we can see some generic rules as well. Anything that might have a wildcard that might be of concern, we'll kind of try to show you this within the insights page. And again, we have potentially malicious sources for threat intelligence and IDPS for specific events that are going through that Azure Firewall as well. I'll show you the network rules tab here. The DNAT rules and application rules are pretty much the same, but what we're looking at here is pretty much the top hits or the hit count for your network rules on an Azure Firewall policy. And you'll be able to kind of see who your top talker is within a specific type of rule collection, whether it's going to be network or it's going to be application. But what I really like here is the traffic flows. So traffic flows kind of takes the DNAT rules, network rules, application rules, and puts it all into one tab. And it really shows you who your top talkers are for the last day. You could change this for some certain periods of time, but you'll be able to see who's the source, who's the destination, what port, what protocol, and how many times are they communicating within this last 24 hours. So this is a pretty good way to really determine those top talkers and to see if there might be something that's a little bit abnormal that might be going on with the Azure Firewall. If you're seeing that two endpoints are communicating much more than they should be communicating on, or if they're communicating on ports that are unexpected that maybe slip through certain rule configurations, then you'll be able to see this here and then go through and then to quit that. Last thing I do want to show you here for the policy analytics is what I think it really makes it very powerful is the single rule analysis. So if I come here and I click select a rule, I'm going to click on this defend the flag. All right, perfect. Just a little trance here for those little dots going up to on the top. So the single rule analysis, I've selected defend the flag, and what this is going to do, it's going to show me how my rule is set up today. So it's showing me that I have my port is set to any, my protocol is set to any, and my destination is set to any. And then for my source IP or my pretty much my source address space. It is, relatively large. It's a /24, 255 IPs here that's set up for this rule. It does say, it does give us some warnings here about, hey, be aware that there's an any here within your rule. Now, but if we scroll down to the actual rule recommendations, we'll be able to see exactly what is going through. So the policy analytics will grab everything from the Azure Firewall policy and it'll say, hey, this is what's going through. This is the ports that are going through, and these are the protocols that are going through. Do you want to change this rule to better reflect what the actual traffic that's going through there? You can then deselect or select whichever ones that you want to actually change, and then you'll be able to apply that by clicking the apply selected changes to the rule. Very powerful, very cool way to see how you are actually programming or configuring your rules and then seeing exactly what type of traffic is going through those specific rules. So this is a really powerful tool. I really like this tool and showcasing this here. Last thing that I want to show you before I hand it back over to Gustavo is just a quick example. And sorry for the contrast, we just went from bright white to some dark blue here. But this is an example of a Terraform script. This is actually one of them in our GitHub repo for a firewall basic SKU. So if you wanted to kind of test out the firewall basic SKU and you are a multi-cloud, you have a multi-cloud stance and you utilize Terraform, you'll be able to go into our GitHub repo and check this out. So as you can see, here is our Terraform. And here is our resource types. We have our firewall policy, and then we have our rule collection group. So we are able to take those rule collection groups that I was mentioning before, like workload 1-production. If you wanted to make that its own rule collection group, so just one individual had the ability to manage that, you could do that. It has its own child dependent resource. And then lastly here, we have the actual Azure Firewall resource when it shows the IP configurations and the management IP configurations. Lastly, this is just the same template here, but it's just in the bicep flavor. So if you are just going to use first-party Microsoft tools for your management, this is the same one, same exact environment that will be deployed, just using the bicep. We have our firewall policy name. Our rule collection group is split out. And if we come down here, we can actually see the firewall itself with our management and IP configurations. All right, and now I'll pass it back over to Gustavo.
All right, so let's start our last section, which is troubleshooting. Troubleshooting is just as important as monitoring and managing the Azure Firewall. Having tools available for troubleshooting Firewall is important because they can help network engineers and admins monitor network performance, identify and resolve issues, and prevent potential cyber attacks. So in order to help you all, we do have some features available for troubleshooting. All the features that we are covering here right now, they are in public preview. Okay, so the first one is the flow trace logs, which is which is a feature in public preview, and it helps admins to see the traffic return flows, failed connections, or unrecognized packets hitting the firewall. Currently, the Azure Firewall logs show traffic through the firewall in the first attempt of the TCP connection, known as the SYN packet. And however, this doesn't show the full journey of the packet in the TCP handshake, right? So if you go to the network rules, you are not seeing all the packets going back and forth. You're gonna just see the SYN packets over there. As a result, it's difficult to troubleshoot if a packet is dropped or asymmetric routing has occurred. So in these flow trace logs, it captures the following flags to help with troubleshooting efforts. So we can find SYN-ACK, FIN-ACK, reset, and invalid packets. The invalid means invalid flows, indicating a packet can't be identified or doesn't have any state in the firewall table. So let's say you have a VM replying SYN-ACK through Azure Firewall, but the Azure Firewall never saw the SYN packet coming in. That traffic will be dropped because it doesn't know the state of the flow. To avoid excessive disk usage caused by flow trace logs, we highly recommend to enable to activate the logs only when troubleshooting a specific issue for diagnostic diagnostic purpose. And just one thing to mention here, this is only available for the structure logs. So if you're using your diagnostics, you won't be able to enable these flow trace logs category. And that's the same for the next one that I'm just going to talk about, which is the flow trace logs. But let me just go through what's needed for enabling the flow trace. For enabling the flow trace, since it's a public preview feature, you're gonna need to enable the structure logs, and you need to run this PowerShell command here at subscription level to enable the feature flag in your environment, right? So this is the command. We also have the same PowerShell command in our documentation. So if you never use the flow trace logs, please take a look at that. Make sure that you have the feature flag enabled, and then you can configure the category in your structure logs to start using it. Okay, so the next one now is the top flow logs. So the top flow logs, sometimes, traffic flows can either be unintentionally or intentionally have, depending on the size, duration, and other factors of the packet. Although Azure Firewall Standard can support up to 30 gigabits and Premium can support up to 100 gigabits, these flows can potentially impact other flows and processing of the Azure Firewall, making it slow, and some users having the slowness experience and then reporting to the IT teams that something's wrong with the network, right? In our example here, the screenshot, we have a column named flow rate, which shows the flow rate of that specific flow. In this case, in our first log here, it shows a flow rate of 0.069, which will equate to around 69 kilobits per second. Similar to flow trace logs, only we recommend only enabling it when you are troubleshooting a specific issue, because it requires CPU usage on the Azure Firewall to process the flow rate and then makes these make these logs available to you. This is also an example. Since this is a public preview feature, it's not enabled by default. Some prereqs, you're gonna need to use structure logs and then run the following PowerShell command. The difference here is that this PowerShell command is per file and not really per subscription. So it's important to enable the feature running this PowerShell command in case you want to test and use these logs for troubleshooting. Now we have the latency probe metric, which is a feature, which is a metric, designed to measure the overall latency of the Azure Firewall and provide insight into the health of the service. We can use this metric to see if there is any kind of latency between on the communication between the Azure Firewall instances. It doesn't show really the latency added by Azure Firewall in the network flow, right? But it gives you the idea if there is something wrong with the Azure Firewall. So if we see the latency, let's say higher than 1 millisecond or higher than a few milliseconds for a long period of time, that would indicate that something might be wrong with the Azure Firewall, causing a bad user experience, like slowness in your network, and then you would need to engage the support teams to help you investigate what's going on with the Azure Firewall instances. So we can create some alerts in order to get notifications if the latency is higher for a long period of time, helping us to proactively reach out to the Microsoft support teams and ask for help trying to identify what's going on. And lastly, we have the Azure Firewall Resource Health Check, which is a health check that helps us monitor and see what's going on with the Azure Firewall as well. It's a feature that was available for other resources in Azure, but it wasn't available for Azure Firewall. And then it's now being integrated. So you can see some different statuses indicating different levels of impact on the Azure Firewall functionality and performance. These statuses are available, unavailable, and known or degraded. It shows two types of events, platform and non-platform events that can affect the health of a resource. Platform events are caused by Azure infrastructure issues, while the non-platform events are caused by user actions. And via resource health, we also have access up to 30 days of health history and root cause analysis report for platform-initiated and unavailability events. So this is another tool that helps us troubleshooting and try to identify issues affecting Azure Firewall and consequently affecting users and applications. This was a quick section. Now I'm going to hand it over back to David, which will drive the last demo of the day.
Thank you, Gustavo. Actually, Valen, I wanted to be very mindful of our time here. I see we're kind of close to the end. Did you want us to just kind of take some questions, or should we continue with the demo here?
How long will it take you for the demo?
It should only take a few minutes.
Let's go for it.
All right. Okay, so I'll start sharing my screen. So we'll talk about the flow trace and the fat flow that Gustavo had just mentioned. You'll come to the Azure Firewall overview, you'll come to the logs, and then you'll be able to just use these very easy specific queries within Custo query. So this one is the first one. This is AZ Firewall Flow Trace. This is a way to determine within your network if you're going to have some type of asymmetric routing, if communication is actually making it to the destination server, and you're able to see that SYNAC flow. So let's see if I can find some examples here. So this flag invalid. So what we're seeing here is this is a asymmetric routing. So we are seeing a SYNAC come into the Azure Firewall, but we were never able to see the actual SYN. So we didn't see the beginning of the flow. We're seeing a second portion of the flow. So for that, we are going to say that this is invalid flow for the Azure Firewall, and most likely, well, not most likely, we will drop that. Very typical behavior for firewalls here. We see FIN, we see SYNAC. SYNAC we do want to see whenever we're doing some network troubleshooting. This determines that, hey, we sent the SYN and we are at least getting the SYNAC back. This is going to most than likely ensure that we have a three-way TCP handshake between the two endpoints. And that's what we want to see when we're doing network troubleshooting there. But then we have FIN, we also have FINAC. And if there was going to be a reset sent between one of the two parties, we would be able to see that within these logs as well, if that's what you're trying to find within your troubleshooting. Next, we'll look at fat flow. This is another way to determine what is going on through the Azure Firewall, who are top talkers when it comes to bandwidth, not necessarily how many flows are going through, but when it comes to the bandwidth. Let me change this. Let me take out this take 100 and see what else we can get here. I know there were some flows in here before. All right, so here are some pretty significant flows here. So we can see that between this public IP and 10.0.25.6 here, that we have a pretty significant flow that's going on. There's a pretty large, either maybe a file that's being uploaded or downloaded between one or the other, but we are able to determine that there is a pretty significant talker, at least from the source IP there. So this is a way for you to determine what is going on through the Azure Firewall, if this is potentially hindering performance when it comes to bandwidth or anything like that. Next, just two more things here. One is going to be the metrics, and the last will be the resource health. For the metric here, this is the latency probe. You can see that we actually jumped up a little bit. There was a very small jump in our latency, but as you can see that it came back down, and there was nothing that was actually shown up, and there was no hindrance within the environment. So we say this is a very typical way that you would see the Azure Firewall. Depending on how large your Azure Firewall will be, this is a premium SKU that you're seeing here, but not much bandwidth is going through. So we're kind of at 2 instances. But let's say you are scaled out to about 15 instances. This might look a little bit different to you, but we are looking around that 1 millisecond time frame. If you do see just a sudden spike and it comes back down and no one ever said anything, then there's really no need for concern. There's only need for a concern or for you to open up a support ticket with us if you see this really out of control and you have users that are complaining about specific flows maybe terminating or whatnot. Lastly, here is just the resource health. You'll be able to see if there's anything that actually happened and be able to get RCAs for at least the last 30 days. But this is all really the troubleshooting that you'll be able to use when it comes to the Azure Firewall. All right, Valen, that's it, sir.
Thank you. Although most of the questions were already answered by the team, there's 3 remaining here, so let's try to wrap them up here quickly. Is there Terraform for Sentinel firewall connector?
I do not know if there is a Terraform provider or there's the Azure RM provider, but I don't know if there is a Terraform resource specifically for the firewall connector for Microsoft Sentinel. I don't know that.
Okay, we'll check on that later. Thank you for that. Is there a way to query the health status from API instead of going to Azure portal?
Gustavo, do you know about that?
That's not available today. The help status that we have available for customers is really the resource help today. There are some improvements. The resource help is bringing some improvements which were not available in the Azure Firewall before, but we would like to learn more about this. So if you can submit a feature request and give us more example, would be really helpful.
Great, thank you, Gustavo. Doesn't the structure logs provide the same information as the flow trace logs?
Actually, the structure logs is just the schema or the new tables that are created. When we talk about the flow logs, that's a new table which shows all the flows in a flow. All the flow from a specific connection, right? So, for example, if we check the network logs or the application logs, we are not going to see all the subsequent packets over there. So it shows the flow logs is part of the structure logs, is a new category available in the structure logs, and it shows a different information or different kind of data that when we compare it with the network logs, DNet logs, or application logs. But they are all part of the structure logs.
Thank you, And I'm noticing there's some questions regarding some features and all that, but for deeper conversations and how you can influence our product designs, as well as getting early access to changes through private previews, as well as learning about our product maps, you can join our CCP team or a private preview community at aka.ms/join-private-community-ccp. This link has been shared at the very beginning as well as here. So I think we've gone way over the top of the hour here. So thank you, David and Gustavo, for being our guest today and for sharing this valuable information with our community.
Thank you, everyone.
And please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.